Welcome to this series of Key Git Concepts Fundamentals to Advanced Workflows. In this series, we embark on an in-depth exploration of Git, which is a cornerstone technology in modern software development and a very crucial tool for DevOps and cloud engineers. Here, we aim to decode and explain Git in a very easy to understand method. And let's illustrate its vital role in version control, which is a foundational requirement or a discipline in software development teams for efficient collaboration and seamless automation, including the DevOps and cloud engineering. We begin by establishing a solid understanding on the basic concepts such as repositories, commits, branches, and merges. As we advance, we delve into sophisticated workflows and best practices that leverage Git to manage complex projects and foster communication, continuous integration, and deployment, which are the key components of DevOps practices. As we advance, we'll delve into sophisticated workflows and best practices that leverage Git to manage complex projects and foster continuous integration and deployment, which are key components of DevOps practices. Moreover, for cloud engineers, mastering Git is equally important as it facilitates the versioning and tracking of infrastructure as code and configurations, or IAC, which is essential for managing scalable and distributed systems on cloud using tools like CloudFormation, Terraform, Ansible, Chef, etc. By the end of this series, you'll not only grasp the fundamental to advanced workflows of Git, but also appreciate its profound impact on the fields of DevOps and cloud engineering, which will enhance your capabilities to tackle modern software challenges. Let's dive in and begin our journey into the powerful world of Git. Let's start with the concept of Git repositories, which are the fundamental building blocks of Git's version control system. These are central to Git's version control capabilities. A Git repository is not just a place to store files. It's a powerful tool for tracking changes, enabling collaboration, and managing complex software projects. Let's understand what are repositories, from their basic structure and initialization to their role in tracking projects and facilitating collaboration among team members. We'll start by defining what a Git repository is and how it differs from other storage or versioning systems you might be familiar with already. We'll also discover the core components of the repository, the difference between local and remote repository, and then we'll further discuss the importance of the role of remote repositories in enabling distributed version control. We'll also discuss the core components of a repository, the difference between local and remote repository, and we'll further discuss the importance of a remote repository or remote repositories in general in enabling distributed version control systems. We'll also discuss the core components of a repository, the difference between local and remote repositories, and then we'll further explore what are remote repositories and the importance of them, the remote repositories in enabling version control systems in large projects. Repositories are indispensable for the developers, particularly those in DevOps and cloud environments, where efficient, traceable, and secure handling of code and source code or the projects or the changes are critical. Repositories are indispensable for developers, particularly those who are working in a very professional environments, especially those who are already have a DevOps and cloud environments, DevOps or cloud environments, where efficiently trace and securely handle the code changes, which are very critical for the professional and mission critical systems. It is crucial to understand the structure and the purpose of a Git repository to leverage Git more efficiently in your daily work. Understanding repositories is key to mastering Git because they serve as the backbone of all the other components and the operations and workflows you will encounter in your day-to-day operations or day-to-day development process. To get started with version control, or as a seasoned developer or DevOps engineer aiming to refine your Git skills, this section will provide you with the necessary tools and knowledge to effectively manage your projects using Git repositories. Let's begin by exploring what makes Git repository unique and essential to the Git workflow in your day-to-day operations as a developer or as a DevOps and cloud engineer. What is a repository? Think of a Git repository as more than just a storage unit. It's a central command center for your projects, where all your files, every piece of history is meticulously recorded. Think of a Git repository as more than just a storage unit. It's a central command center for your projects, where every file and every piece of history of every file is meticulously recorded. Here, all your project's files are not only stored, but also the entire evolution of the file is tracked. You start with smaller changes, you create a new file, and then you add extra modifications, and then you commit. Then another day you revisit and add another method or another line, another feature into that file. And so a file or even a project or a folder goes through a lot of evolution, a lot of growth stages. So Git repository will record all your changes, provided you keep committing each of your changes with proper comments and proper care. A repository in Git serves as the backbone of your version control system. It is here in the repository Git tracks every change made to your file, making it possible to collaborate seamlessly with others, with your team members, right? So you start with the file and you make some modifications, and one of your colleagues or your team members will go and check it out and make their own modifications and commit it back. So in a collaborative work, Git repository records each and every change coming from different users, different team members at different timelines, with the additional comments or whatever specific feature you are, specific kind of tracking you are enabling or helping Git to record. Git records everything, and after a period of time you can go back to the history and you can see the whole evolution of that file and a folder or even a project within that repository. Whether you are adding new features, fixing bugs, or experimenting with a new different development branches, or refactoring a set of existing code, and you are improving the performance. So whatever change you make, Git records all of them, and depending on the kind of comments you add, it allows you to reverse or go back or even revert back to a previous version of the history. The repository keeps a comprehensive record of all the changes you and your team members make on a specific file or a folder or an entire project. This feature of recording changes by the repository, this enables that the team can work together without overwriting each other's change. So this allows you to collaborate easily without any conflict. So this helps you to work collaboratively and in a very effective manner. Moreover, a Git repository is akin to a time machine to your code. It allows the developers to travel back to the earlier versions of the project, providing the flexibility to review the changes. And so this allows you to your code review and accept the changes or revert or reject or suggest modifications, or even retrieve the lost work. Suppose if you have lost or overridden some work, so it allows you to go back to a specific previous version and take only the snippet you have changed, and update it and push it as a new version. So this is the capability of a repository, which is very invaluable, and it's very critical to understand these features of a repository for an effective software development process and DevOps pipelines or the DevOps processes. And for undoing the mistakes without disrupting the current state of the project. This capability of reverting back or keeping the history and going back to the history and rolling back some changes, ability to roll back the changes, understanding this and using it effectively is very critical for the proper or effective collaboration of team members in small to large or medium or large projects. So you understand that Git repository is not about saving files. It's about empowering the developers to control with control and collaboration and the confidence to innovate at any scale without having any conflict. So this allows the innovation and collaboration among the team members. Let's explore how this powerful concept of repository can revolutionize or facilitate the way you manage your code and collaborate within your team. Let's break down the anatomy of a Git repository into 3 essential components, each serving a unique and crucial role in managing your projects. First, we have the working directory. This is your project's playground. It's where you spend most of your time creating, editing, and organizing your files in their crucial states. So this is on your local machine, and this working directory represents the immediate environment where all your changes happen in real time. So this is where your work is happening, actual work is happening. You edit your file, you modify, or you add new lines, new features, or you refactor. This is the place. So this is your working directory. Next is the staging area, and it's also known as the index. Think it of a prep room for your files and changes. Before any change is finalized into the project history, or before you push, it passes through the staging area. This is where you fine tune what will go into your next commit, allowing you to precisely control over your project's version history. You may not commit all your files, so you will add into the staging area, and you'll decide later what changes or what files need to go into the commit when you commit next. So before or between your initial, your working directory or your initial changes, you add to the staging area, and you decide before you commit to the final changes. Lastly, we have the Git directory. This is the control center of your repository, and this directory is actually hidden away from your normal site, and it is called the .git directory, which you can see under the direct root of your project, your Git repository, and it holds all the critical metadata of your repository, like all the commit history. And it includes the branches, and it includes the tags, it includes all the comments and all the timelines and all the objects that make up your project. Okay, and it is the core that tracks all the changes and maintains the integrity and the history of your work. This enables you to go back in time and go back to a previous version and record all the changes and collaborate with your team members, so they can analyze who made what kind of changes when. So this is where everything is recorded. So now we know that, okay, the Git repository is made up of three primary components. One is the working directory, the second one is the staging area or the index, or the third one is the Git directory. Understanding these concepts will enhance your ability to manage your projects efficiently, and it will allow you to leverage the full capabilities of Git and Git repository. And each component plays a very strategic role in ensuring that your software development process is smooth, your collaboration is getting effective, and your ability to track changes are you're preserved by these components. Or even it makes your code reversible as needed. Repositories can be local, allowing you to work independently on your machine, or remote, facilitating collaboration with your team members. Yeah, and it will serve as a backup. Yeah, so there are distinctions and roles for remote and local and remote repositories within Git's ecosystem. Each of these local and remote serves as a critical function in the life cycle of your projects. First, let's consider the local repository. This repository resides directly on your local machine. This is where you spend most of your time. This is where you work and update your changes. You add new files, and this is your workspace. Yeah, so this is where you commit first before you push to the remote. So every developer, in a team, there are multiple developers work their own respective local repositories. And once the changes are stable, they commit locally, and once it is ready to be pushed to the remote, they can push to the remote. The local repository is where you will do most of your work, making your changes and testing them out in real time before anyone can actually see it. On the flip side, we have the remote repository. Unlike the local repository, it is stored on a server, so it's not on your machine. It could be in platforms like GitHub, GitLab, or Bitbucket, or any other public Git provider, or your organization-wide remote repository, a central remote repository in an organization where you do not share with over the internet to anyone else, because this is just for your internal purpose. Yeah. So this remote repository is the key for collaboration among your team members, acting as a central hub where each team member can push their local changes, and the other members can update the changes from others and take it local, and then continue working on those changes. It's also another use case of another benefit of this remote repository. It serves as a backup, on a central location of all your projects. Generally, These remote repositories are architected or designed in a highly available fashion where there are multiple servers with either active or maybe active passive, generally active passive, high availability mode. If one of your servers crashes, the other one will take over. So you can recover from the other one, backup. And generally, you need backup strategies for that. Yeah. So understanding the interaction between local repository and remote repositories are fundamental to work on a Git environment. Yeah. It enables a very fluid workflow, a seamless workflow where developers can work independently on their local machine while collaborating to the team members seamlessly without having the trouble of overwriting or losing the work. Let's summarize the significant advantages that Git repositories offer, which underpin the widespread adoption in the software development world. This made actually the Git as the most widely used version control system, replacing all the predecessors. Firstly, we have version control. That is the first feature, the basic feature. Git repositories provide a robust system for tracking each change to your project files, your folders, your projects, the project as a whole. And this tracking allows you to see who changed what when. This allows you to revert back to any previous version. Yeah. Previous version if required, if there is any conflict. So this is very highly important in projects where there are more than one person or maybe many people are working together on the same set of projects, same set of files in a single project. Yeah. So if whenever something goes wrong because of any overriding or any make any error you have made by yourself without knowing it, so you can always go back to a safe earlier version with the help of this tracking. Yeah. This feature, this ability to track or the version control feature is very invaluable for maintaining a stable development environment and for troubleshooting. This is a critical component in a general software development environment. The next feature is collaboration. Yeah, Git excels in providing support for collaborating with multiple developers in a team in the same project. With Git, team members can work on different parts of the project, or in the same file itself. Same file, multiple persons can work together at the same time simultaneously without interfering with each other, without having any conflict or the risk of overwriting another person's work. Once each developer's changes are ready, they can merge these changes together in the main project. So there are features like merging, and reverting back and comparing with each other. It allows you to compare and see the changes side by side. And this allows you to streamline the team workflow, and it will enhance your productivity. So you'll not spend a lot of time comparing in a unrelated two different text notebooks or anything. Yeah. So Git provides built-in functionality to see the changes, see the diff. There are many different commands for that. Yeah. And whenever you find a conflict, you can make the changes and then commit it again. So even those changes, any corrections are also recorded by Git, so that you have the complete history and ability to roll back or revert back later. Yeah. Another powerful feature is branching. Git allows you to create multiple branches on a repository for different reasons, whether it's for a new feature or a bug fix. You can create a new branch and you can work in parallel. So this enables you to multiple people in a team can work in parallel about the same project, and later they can come back and merge together before you release it to the production. This means you can develop new ideas or resolve issues in an isolated environment. So each branch is an isolated environment which doesn't affect without affecting the main code base or without affecting with another person's work. So this is clean. This allows you to work with clean separation. This gives you clean separation. Once the new code is tested and approved locally in that branch, then you can merge it back to the main branch or the release branch. Yeah. And this simplifies the software development process and again allows collaboration. Yeah. So this is a critical component for collaboration and again tracking changes. So you can track changes across multiple branches of the same repository. The last feature is the distributed nature of Git. Yeah. Each developer works with a complete copy of the entire repository. So whenever let's imagine there are 3 people working in a team. Each of them have a separate independent copy on their local, and their change history is separate. And their local changes are recorded in their own machines, and whenever you push to the central server, it takes all this metadata to the central server. So this setup not only makes the work easier, yeah, this allows you to work offline without being connected to the internet all the time. So you make all your changes locally, your local repository keep recording all the changes, and finally once you push when you have the internet connection or the network connection to the central repository, all your changes along with the history goes to the central server, and this will be available for everyone else in the team. Yeah, if the server hosting the remote repository goes down, any of the clone repositories are not blocked. You can continue working locally. So regardless of that server crashes or network outage or whatever happens to another developer or any other outage, any other disruption can be accommodated easily. So this allows you to work independently without any problem. Yeah. So by leveraging these benefits like version control, collaboration, branching, distributed nature, and there are many other benefits for Git, of course, Git repositories. So these are top benefits. Yeah. If you leverage these benefits, Git repositories will not only improve the efficiency and quality of your software development projects, but also it will foster a very collaborative and flexible working environment. So all these features of this Git repository made Git one of the most wanted, most favorite of everyone. Yeah, most favored version control repository, version control system in the world. Now we'll examine the practical example of a practical application of Git repositories in structuring and managing a real-world example project called the Medibooks application, Medibook system. This clinical management system illustrates how Git supports modular architecture, modular development practices, and enhanced collaboration across different parts of the application with your team members. Each of these modules represents a module. Each module becomes a repository. So typically this is a microservices based architecture. First we have the Minibooks public web module, which is a repository dedicated for the front-end development of the Minibooks platform. So the front-end developers work on this particular repository. We can consider this as an Angular or React based application, where all the front-facing features reside, or the front end is residing there, making it crucial for delivering a seamless user experience. So this is for the front end. By maintaining this front end in its own repository, the front end team can just focus on the UI environments without interfering with the backend logic. So only the front end developers work here. The next module is the Medibooks appointment service, which is a backend service. This repository houses a microservice, backend microservice written in Java and Spring framework, especially designed for managing the appointment bookings and its API. Keeping this service in a separate repository allows the development team of the backend services just focus on the backend business logic and iterate quickly on the features like scheduling and cancellations and booking and everything, independently of the other services like a front end or any other services, any other modules. Yeah, we also have the Medibooks user service, a Node.js based, for an example, a Node.js based service responsible for the user authentication and it manages the security. This critical piece of the system handles the user data security and efficiently it isolates its own repository. Using this repository, it isolates that business concern of security into a separate module and a separate repository. This allows the people who are well versed, the subject matter experts of the authentication and authorization logic, they just work on this repository. So this ensures any of their changes, their improvements in security, their changes in the security doesn't affect the other parts of the application, other modules. Yeah, so all the data, all the business logic, everything, all the authentication protocols, everything resides in this repository. That doesn't affect others. Yeah, so they work purely based on a contract called API, Application Programming Interface. So this is architecture. Also, this repository structure supports that microservices architecture without interfering with each other. Okay. Lastly, we have the Medibooks admin portal where the administrators go and manage the application system without interfering with the normal functions. This could be built using React or Angular. So this is again a front end, which is an administrative module, a front end system. This repository is key for the admin team to manage and deploy updates without affecting the user-facing components of the system. So there is a clean separation from the root level, from the repository level. So it supports the architecture and it allows isolated work, or with the clean isolation between these development teams as well as the modules. By using these separate repositories for different components like components of the Medibooks project, each team can focus now on their specific tasks with the minimal dependency issues, and minimal invasion over the other modules. This setup not only simplifies the development and testing, but it also streamlines the deployment processes, for the DevOps engineers, for the cloud architects. To deploy these services, deploy or even taking updates of each of these modules without interfering with each other in a smooth and stable manner. And it is easy to be configured with the CI/CD pipelines or any deployment servers separately. So you don't need to deploy everything together. So you can keep them separate. Whenever there is let's say we have some changes on the front end, you just need to deploy that module. You have some changes on the authorization mechanism, authentication mechanism. You just modify this repository, work on this repository, and deploy only that repository. So there's a clean separation between each other. So that is the original architectural goal, and this division or this separation, this structure of the repository in alignment with the architecture. Allows you to work seamlessly. So that's how Git becomes a very valuable tool to support modern architectures, modern deployment methods, modern deployment platforms seamlessly. All these features of this repository, or the ability to categorize, ability to separate this repository into its own business concerns, allowed Git to become the most favorite source control mechanism and tool among all the developers, DevOps teams, and the operations teams. In the example of Medibooks application, we have seen there are multiple repositories. We have seen 4 different repositories. What are the strategic reasons behind structuring such large projects with multiple Git repositories, and how this approach can significantly enhance the project management and development scalability? Let's take a look. First, let's talk about separation of concern, which is a very important concern, very important aspect or the benefit. By using multiple repositories, each team and each component can be dedicated into a specific component. Each repository can be dedicated into a specific component or a service within that project. This focused approach reduces complexity. Because changes in one part of the system doesn't directly impact others, any other project or any other submodule, or any service or a team. For instance, a backend service dealing with the data management or persistence into the database can be developed completely independently of the front-end user interface or the front-end module, ensuring that developers of the backend can work without stepping on each other's toe, without having any conflict, and that each part can be optimized without compromising the whole project. Next, we have team collaboration. When different teams are assigned to different repositories and different parts of the project, it minimizes the chances of conflicts and overrides. So it allows team can work simultaneously without having any conflict. So it speeds up the project development. It improves productivity. For example, the UI team working on the client-side repositories and client-side application, and the backend team work on the backend or the server-side business logic, can operate in parallel without without waiting for each other. So it saves a lot of time. It avoids any waiting period, and it avoids any conflict. And this allows them to speed up the development in parallel. And finally, they can come back and merge and test them together in a very seamless manner. And it will speed up the overall development process while maintaining the clarity and order in each code base, each of the repositories. Lastly, the advantage of scalability. As projects grow and evolve, having multiple repositories gives you a lot of advantage. This will allow each component to scale independently, and you can add new modules into the whole picture. So let's say now we have seen 4 repositories, right? So in order to add a 5th repository, since we already have that structure and the culture in place, it is so easy to add a new repository and a new team or a new team member into the group without having any conflict or without having any friction or any downtime or waiting time for the development period. This modular setup supports more flexible development and deployment strategies as well. When you deploy to the testing environment, production environment, other modules doesn't need to wait for the whole thing. So each independent module can be deployed, tested, and tested and deployed independently. This enables the team to upgrade, or even pivot parts of the system without disrupting the entire application. Yeah, so that's a big benefit. It also makes it easier to integrate with the new technologies or frameworks as needed. Big example is that we have seen in the example of Medibooks. The front-end technology is the front-end application is working on Angular or either React. On the back-end services, each of them can be one can be in Java Spring, another can be in Node.js, another thing can be Python, depending on the availability of frameworks, depending on the team strength or their capabilities, etc. So we have total flexibility having this kind of modular approach. It also makes it easier to integrate, any approach, any new architectural approach within that application without affecting with each other. The only thing is that there should be, very clearly defined contracts in terms of APIs defined in order to, having any conflict. So once the data contract in place, this modular approach will allow you to work in parallel, very smooth, very fast, and without having any downtime. Another big example is that if you have in the overall picture, you are seeing some performance issue or some bugs, or some business logic problem in one of the modules on one specific area. You just need to work on that particular module, and you can deploy without affecting each other, without affecting the other modules itself. Yeah, so it makes you, so much easy and fast to develop the entire application. Yeah. By structuring large projects with multiple repositories, organizations can achieve a higher degree of modularity, hence flexibility and maintainability. You can maintain each of these modules separately, right? So it doesn't affect all the others. And agility, you can move much faster. This approach not only facilitates better collaboration, here working together as a team across diverse teams, but also aligns with the modern software development practices that require rapid adaptation to the CI/CD, or deployment platforms. It gives you portability. Yeah, so it can adapt to any new changes in the operational mechanisms you employ on the production systems. And most often this required rapid adaptation. Many of the growing applications requires rapid adaptations for the changing environments, changing requirements, changing business needs, etc. And robust project management. So yeah, from the project management perspective, this is very flexible. You have more choices. So these are the overall benefits of having multiple repositories for a single project. Now, having enough concepts about Git repositories, let's look at 2 fundamental Git commands that are vital for setting up and accessing repositories. These commands form the basis for any Git project, any Git workflow, that are essential for starting new projects as well as working with the existing ones. Okay. First, we have this git init command. This command transforms the current working directory into a full-blown Git directory, Git repository. It creates a new .git directory under your root folder where all the version history and Git settings, all the metadata related to Git will be stored. It will be generated. So this directory will be used to track all your changes you are making, and then it will share with the server when you finally push it to the server, to the remote repository. And this is the first step you can take when you start a new project under Git version control. It's like laying a foundation for a huge building, a new building, which is the starting point from which all your projects version control capabilities will start and grow. Okay. The next command is the git clone command, a very important git command. This command is used to create a copy of an existing remote repository. In our example, git clone the Medibooks public web folder, web directory, web project. This command will clone the Medibooks public web repository from the remote server to your local machine, your local directory, the current working directory. And this is particularly useful for contributors of this project who needs to start working on this particular project by obtaining the latest version of the code base from a remote repository. Let's say you started the project and you made all the changes and you converted into a git repository by typing the git init command, and then finally we're using some other commands like git commit, add commit, etc. And finally you push to the server, and after which you obtain this URL from the server and share it with one of your colleagues, your team member, and that team member can clone using this git clone command to his local, and he can start contributing into it. And finally, so this is a beginning of the collaboration. Yeah. So we'll discuss all the other commands later in the later sections of the series. And together, git init and git clone are the entry points into any git-driven development environment. Yeah, any project. This allows the developers to start new projects or join an existing project, existing repository as a team member, and start collaborating, start contributing. And understanding these two commands, git init command and the git clone command, are vital, and it's crucial because the understanding will enable you to effectively create and manage repositories, whether you are working as an individual contributor or even you are working in a team or even in a very distributed team. Before we conclude this session about repositories, which is the foundational building block of Git, let's just recap and just look at these top 4 repositories of the Medibooks project. The first one is Medibooks project, Medibooks frontend, which handles the UI UX, or the front end, the client interfacing public module as a repository. The second repository is the Medibook appointment service, where all the business logic related to the appointment booking is handled in a server-side technology. And the Medibooks admin portal, which is more managed by the operations and the administration team, which could be either a single API-based backend or a combination of backend and frontend. It could be anything. Yeah. And the last one is Medibooks integration test, which is completely for the testing purpose, which will not be deployed on production. And this is a repository dedicated for all the integration tests that connecting all the pieces together. Yeah. And this could be a starting point of the Medibooks project, and it can eventually grow into many other modules, like security module, which handles authentication and authorization with a custom code or any technology, or a readily available authentication or security module like a Keycloak or Okta, any such kind of thing. And there could be a dedicated reports module, a report service that is developed completely in a custom code or another reporting engine embedded system. It could be in any technology. So depending on the team's flexibility and their business decisions, they can keep adding repositories into that project. Yeah. So I hope this session about the repository was very helpful for you, and which gave you a clear understanding about the concept of repository. And in the coming sessions, we'll be discussing more advanced topics of Git, including how to collaborate, how to push, pull, and how to create branches, tags, and different types of Git workflows, etc. Until we see you the next time, goodbye.